with the weather and meteorology. Yeah, Shailesh.
So I have one question about the same scenario. When we are talking about the confined space, so in confined space, we do not have the much air velocity. So does it affect our flying condition?
Yes, yes, of course. So, for example, in mines, okay, mines is altogether a different environment. Okay, there you do not have air, oxygen is very less, air is very less over there. Then you do not have a GPS signal also over there. So all these challenges are there. In that scenario, normally what happens when you are flying a drone, let's say for example you are flying a drone in a mine, there are separate sensors or separate what do we say, coordinate systems is been, I mean, there will be artificial coordinate system which will be created, which will be guiding, or probably it would also have a radar, terrain radar kind of thing. Okay, so there will be radar sensors would be fitted on those particular drones, which actually measures. The drone has to be in the center of the mine kind of thing, at that particular place. So it should not be near any wall or anywhere. So it should be flying uniformly in the center and mapping mapping the mine or whatever actions we are performing in the mine. So in that scenario, it will not only fly; it will try to fly based on whatever the aerodynamics it can have. So quadcopter is mostly preferred in that confined space. But then it will have additional ultrasonic sensors or the radars, so that it's not like normally in a drone you will always see it will have a front radar and the back radar and the down radar. Okay, only these three radars will be there. But in a mine you will also have a side radars also on both sides, left and right. Also you will have a radars. Okay, so that means it is completely getting the 360-degree view of the mine, as well as it is able to sense its position with respect to the walls of the mines. Okay, so that is
Okay.
how it will fly in the mine.
Yeah.
Mostly in confined spaces, the more you are able to measure its position with respect to the obstructions or obstacles or the walls, you know, it is able to calculate and keep it safe away from all the what we call that boundaries.
Okay. Okay, sir.
Okay, so when we talk about atmosphere, an atmosphere is a layer of gas that envelops a planet. Okay, Earth atmosphere varies vertically and horizontally in parameters like pressure, temperature, humidity, and density. So these are the four parameters which actually plays a very important role with respect to the atmosphere. If you see, the first layer is called troposphere. Okay, so troposphere starts from 0 to 12 kilometers, 12 to 18 kilometers. Okay, so it varies. So in this, the temperature would be from 15 centigrade to minus 56 centigrade. Okay. Now you might be saying, how can that be so different? So with respect to the height, the difference would be there from 15 to minus 56.5 degree centigrade. Okay. As you climb up, this is actually the range in which actually your aircraft, your hot air balloons, all those are flying. Okay. Even your mountains are up within this range. Okay. So 12 to 18 kilometers. Whereas as you climb the troposphere, you go to its troposphere, it starts from somewhere around 11 kilometers up to 50 kilometers. Okay, even in this, you will see balloons, mostly the balloons, which studies the atmosphere and all. They are also been sent up to stratosphere. Okay, here temperature would vary from minus 56 to minus 2.5. Okay, so sometimes that's what it says. Earth atmospheres varies vertically and horizontally. Okay, so temperature differences would be there. Not necessarily here you are getting 56-degree. That means here also we will have more further. So somewhere within the atmosphere, depending upon how the composition of the atmosphere is there, the temperature differences would be there. Okay, whereas if you see in mesosphere, okay, in mesosphere you will see it is minus 2.5 to minus 86.5 degrees. Okay, so within that range the temperature will be. This is the layer you will see most of the meteors, as well as meteorological rocket, those sounding rockets what we normally send to monitor the atmospheric conditions and all that thing. So those are being sent into this mesosphere layer of the atmosphere. Okay, then we have on top the thermosphere, okay, where you have a temperature little bit higher on the side. Okay, so it is minus 86.5 to 1200 degrees centigrade. Okay, that's the thermosphere. That's why it is called thermosphere. This is little bit hotter because you are exposed to the radiation and all that things. Okay, so you will get a little bit hotter over here, and then above that we have a exosphere where the temperature is little bit high, and you will see mostly the satellites, spaceships, International Space Station. All the your communication satellites or your Starlink satellites, or even the our television network or mobile network satellites, whatever are there. You will see they will be moving in these exospheres. And beyond exospheres is actually where your actually the space starts. Okay, so that's why you see above the exosphere it's shown in a dark. Okay, so because you have an atmosphere envelope on the Earth surface, you will see it is glowing. The sunlight is glowing and all that, and that's why we see in daytime when the sun is exposing to this atmosphere, you will see the light. But opposite side where there is no sunlight, you will always see the sky as dark. Okay, so there are four parameters which actually compromise of atmosphere. You will have a pressure, you will have a temperature, you will have a humidity, and then density. So you saw the temperature, how it varies vertically as well as horizontally. Like for example, if you see troposphere we are seeing 15 degrees. So in a daytime, this particular part of the troposphere, right now we are seeing sunlight, right? So this could be around 15 degrees. But opposite side where there is no sun, it's night, it's the dark. So there you might have a temperature below 15 degrees. Okay, and whereas as you climb the troposphere, you will have a much cooler troposphere. So whenever your aeroplane is flying, let's say your aeroplane is flying at 20,000 feet. Okay, at that 20,000 feet, the outside temperature would be in minus. A lot of time you would have heard pilots saying the temperature outside the cabin, okay, or outside the aircraft is in minus. Okay, a lot of time they communicate this thing. The outside temperature is so and so. However, whereas the inside temperature is a pressurized cabin, they maintain the inner part of the aeroplane in a pressurized environment and maintain temperature kind of thing. If we are exposed to outside temperature, we will not able to survive. Okay, that's why we always have a pressurized cabin in the aircrafts. Okay, so that's why whenever we go high and high up, there will be definitely very less temperature or in minus temperature we'll have it. Okay, so weather is the state of the atmosphere describing, for example, the degree to which it is hot or cold, wet or dry, calm or stormy, clear or cloudy. So if I ask you how is the weather today, what you will answer? You have traveled from home to office. While coming from home to office, how was the weather? Weather
So weather is sunny and hot.
correct, sunny, hot, and clear.
Yeah,
See, the sky was clear today, right? When we are see, if you have seen the sky, it is blue, clear sky, no clouds or anything there in the sky. Okay, but it was hot because we have already started feeling the hot. Okay,
yeah,
as well as dry. Okay. So weather is one factor in modern aviation over which man has no control. So if you see the weather today, how weather is there, we do not know how tomorrow weather would be there. But based on the historical data, let's say we have a data of last 50 years. Okay, whenever we are having these weather stations and all that, they will be having almost more than almost some weather stations have a data of almost more than 100 years of data. So they will always verify, like so and so time. Let's say today is 11th March. So during this time, how was the weather last year? How was the weather 2 years back? How was the weather 3 years back? 4 years? So they will try to correlate. and try to see how the weather is there, and they will do that comparison. So like that they might be compared for last 20 years and then come to know whether the weather is same as last 20 years, and then they will see the differences. So that weather correlation will happen, and based on that they will try to forecast for tomorrow, day after tomorrow, or maybe 7 days in a week. Okay, so that is how the and a lot of time we see weather when they forecast, it goes opposite. Like sometimes MET says that okay, tomorrow it is going to rain, it doesn't rain, and when they say there is no rain, that time it is raining on that day. So we always say that this weather people will never forecast the things because they are also predicting based on the historical data. But since there is no control of a man on the weather, we can't really predict very accurately. We'll try to simulate based on the data, past data, and all the things, but then we really cannot come to a conclusion. But as of now, because of the computational power what we have now, and we are able to compute large set of data, we are more. I'm trying to be somewhere close to predictions, accurate predictions. I would say that. So not necessarily every time our predictions are going wrong. In some scenarios, it goes wrong, but whatever 365 days we see, at least 200, 250 days, the prediction is more or less right. Okay, only it is some days during, especially during the monsoon, you will have predictions going wrong. Okay? Because based on the pressure what is being created on the oceans and the cloud formation happening, uh, you really can't predict how the low pressure would be created in the Arabian Sea or in the Pacific Ocean, and the moment of the hot air and the cold air, and then mixing because of the water, all this uh, ecosystem, you will have a weather cloud formation happening, and then over the period, once this cloud travel over the land and they start cooling down, that's how the rain start falling and all of it. Okay, so meteorology is a branch of atmospheric science which includes the atmospheric chemistry and atmospheric physics, which is the major focus on weather forecasting. To understand the meteorological hazards, their effects on the aircraft, and how to minimize the risk posed by those hazards. To identify the weather information that is required for each flight to interpret actual and forecast weather conditions from the documentation provided. To analyze and evaluate weather information before the flight and in flight. So, a lot of times the pilot, let's say I have a flight to fly from Mumbai to Ahmedabad, or Mumbai to Jaipur, or Mumbai to Delhi, normally, or even Mumbai to Chennai, for example. I will always try to see prior what is the weather condition from Mumbai to Chennai. Okay, if I'm flying from Mumbai to Chennai at 9 a.m., so I will try to see what is the weather, what is the weather. I'll try to get inputs on that, and based on that, because it may be sometimes what happens in Mumbai as of now, we might be seeing that it is dry, clear, hot kind of environment. But as I reach Bangalore or Chennai, I will see the weather has drastically changed, and probably it could be raining in Chennai also. Okay, so we need to know weather pre-hand before we reaching that place. Okay, so since this is a long distance travel and long distance flight and all the things, so you should know. For example, if you are flying from Mumbai to UK, so you need to see how is the weather on your flight path, as you will be passing through multiple countries, multiple geographical locations, and as you reach UK, see, Mumbai is 18-degree latitude or 19-degree latitude, whereas UK would be around 50-degree latitude, 50-55-degree latitude. So there will be a vast difference in the weather, in the temperature, in the density, with respect to the pressure. Again, it depends upon the. Yesterday we saw in the sea level also. The pressure will vary from location to location, and the altitude to altitude. Okay. To analyze and evaluate weather information before flight and in flight. So when you are flying also, that time also you need to keep a eye when the aircraft is flying over different geographical location, how is the weather outside the aircraft? Because that is going to impact or that is going to affect your performance of your aircraft. For example, you always see that your aircraft flying very smooth and very fast in winter season. Whereas when you fly the same aircraft on the same path in the sunny time, so the visibility might be very good, okay, but your aircraft is not performing as much power you are giving it to fly. Do you know why happens like that? In winter, your air performance is very good compared to your performance in a sunny summertime.
Performance.
Because in winter your density of air is very high, whereas in sunny time your density of air is low compared to the winter season. Okay, so you will see sometimes even drag, what we call. See, if there is no air, like Shailesh asked, like in a confined space or in a mine, where the density of the air would be very less. Okay, there won't be much air inside that way. So if air is not there, I cannot fly my aeroplane properly. So I have to put more throttle. I have to keep my engine running more faster compared to winter. In winter, I don't, because the air will also give me, as I give the throttle, since there is more air, there will be air pressure difference on the wings will be more, and that will help me to fly aeroplane more effectively or more efficiently compared to the aircraft flying in a summer season, because there won't be much air. So since no air is there, you will be having a difficulty of flying aeroplane. You have to give more throttle. Okay, so more consumption of fuel, more maneuvering you have to do, because since air is not there, you will not have much lift in the aircraft in the summer. Clear?
Yes.
Yes, clear.
So a knowledge of meteorology will least enable the aviator to anticipate some of the difficulties which weather may cause. A lot of time I've seen whenever we are flying from Mumbai to Delhi, uh, because as we flying, see Maharashtra or Gujarat, these are more like I would say prosperous kind of locations. Green. You will see weather is pleasant, cool in this area. But as you reach Rajasthan, as you reach Jaipur and all, so there the in the daytime when you are flying, you will see that it is hotter. Air is thinner, so you will always encounter, and sometimes because of uh, the cool air from these locations from the sea flying over the Rajasthan, you will see sometimes the cloudy part into those areas. You will always see cloud formation and all that thing happening at the desert area and all that thing. And as you fly your aeroplane through that, you will always encounter as you're flying within the clouds, turbulence and all that thing. So I don't know whether you have encountered or you observed this kind of thing. Whenever I'm flying from Mumbai to Delhi or something, when we reach Rajasthan areas, especially Jaipur, you'll always see turbulence. Okay, you will encounter some turbulence over there or something like that, especially when you are flying early morning or in the evening. Okay, when there is a transitioning happening in the atmospheric conditions also. Like, okay, so that time you will see there will be a turbulence encounter. When you are flying in the afternoon, you will not see that, because that time the temperature will be not varying. But in the early morning or in the evening, you will see there will be a lot of temperature differences you would find uh, from region to region. Okay. So that time you will anticipate that there will be a turbulence. So pre-hand before the flight, it is the job of a pilot to understand what kind of weather is there and what kind of weather he can anticipate on his flight plan. Okay, so that he should be ready. He should be knowing what is what and all of it. So lot of time the pilot will refer the pre-hand data, so that he knows on the flight what plan what he is flying, what could be the weather or what is the currently also. Okay. So in subsequent slides we'll see how to how to know, like if I'm flying from Mumbai to Delhi, there could be Ahmedabad airport, there could be Jaipur airport, whatever the airports are there or whatever the aerodromes are, you can always have the freehand data of that particular airport of that area. Okay, so that is what we called it as METAR. Okay, the letter METAR stands for Meteorological Aerodrome Report. Okay, so METAR gives us the required data such as wind direction, wind speed, etc. needed for safe flying. For drone operation, we need to cross check the METAR for safe and secure operation where we don't risk the drone. Okay, so in a drone flying, since we are not flying very high above the ground or very high in the air, until unless we are flying a fixed wing drone, a normal rotorcraft drone will be flying within the range of green zone. So 400 feet is not going to impact much, but definitely the wind direction and wind speed will have an effect on your drone. Again, it depends upon type of the drone, whether you are flying a small nano drone or a micro drone or even small class drone with less weight capacity like 2 kg or within 5 kg kind of thing. But if you are flying a very heavy drone, like let's say you are flying an agriculture drone, so until unless it has very high wind speed, like where we are talking about more than 15 nautical miles, in that scenario, only the wind would affect your drone. But in a normal like 3, 6, 9, 12 nautical miles, it will not have much effect on the higher weight to ratio capacity of drones, like agriculture drones or supply chain drones, all those things. Okay. So METAR is nothing but there is again it depends whether you want to read the METAR document and find what is the weather or thing. But there are a lot of apps which are available, which you can download and put it in your mobile, like UV, Forest, Good to Fly, Dronecast, Drone Buddy, Air Data UV. I have seen Windy is very accurate, and we have seen it has been used mostly by a lot of pilots. Mostly 90, I would say 95% of pilots across the world follow the Windy app to get the weather forecast more accurately because they have more accurate predictions of the weather for the locations. So you can download this Windy in your mobile and use it as you want to check how the weather is at the particular location. So before we go here, I will just show you the METAR part. So, so if you want to see the METAR, okay, of any location, what is how it is behaving, we can always open in a Google. Okay. Let's say I want to see what is the weather at Mumbai airport. So I will say Mumbai airport METAR. Okay. Normally, we always, as a pilot, mostly the pilot will always open this, okay, and they will try to see the weather condition. So current weather is like the report was made 33 minutes ago. Okay, so wind is flowing at 3 knots from southeast to southeast. Temperature is 32 degrees. So here you get all the information related to those parameters like temperature, humidity, pressure, visibility. See, visibility is 2,200 meters. That means at least you have a good visibility up to 2 kilometer kind of thing. Okay, and it will forecast. Okay, forecast for further time also. Like your visibility could improve to 3,000. So as the day progresses, as the sun rises up in the sky, you see the visibility is improving. Okay, but again, the wind speed could increase like 7 knots, okay, from east to southeast kind of thing, and even wind can go up to 11 knots from the west. So this is how you read the METAR. Okay, normally earlier the METAR means actually is this. Okay, is this. Okay. So whatever is written on the top, earlier the METAR used to come in this format. So you only used to get this kind of information as a METAR. Now because of internet and the information you can get, they have put up into the website in the system. But earlier the information of a particular location, like you are getting it on a mobile or into the small where you have limitation of sending the information. So that time so VABB means this is the what we call the Chhatrapati Shivaji International Airport location. It is then what time, what zone it is talking about. Then you see here 1500 nautical miles and 15 nautical miles. Then what would be the temperature, like 32 or 34, kind of thing they will give you. And then at a standard pressure, okay, Q1013. But there is nothing much. I mean, no significant significance. Means no significance to see that any major issue is not there in the weather and all that. So if there is something there, they would put like cloudy or stormy kind of thing there. So right now there is no significant in the weather as of now. So you see here it is showing the latitude, longitude, and the elevation of the airport. So in Mumbai airport is just 8 meters high from the sea level. Okay. Now let's see the another one. Let's see, like let's say Ahmedabad airport meteor. Now here see, Ahmedabad airport is 23 degrees, longitude is 72, whereas the elevation is 55 meters. Okay, but now here you see repair was made 36 minutes ahead. Temperature is 30 degree. Visibility is 2,500 meters, 2.5 kilometers. We have visibility. Temperature is little bit cooler uh, compared to
Mumbai.
Mumbai. Okay. So temperature here in Mumbai is 33 degree, whereas temperature here is 30 degree. Let's see Delhi also. Now Delhi is, see now, latitude 28 degree. I told you Delhi is 30 degree. So latitude 28 degree, and elevation, see now it is 220 meters. Okay, from the sea level. Visibility you see 3000 meters. That means 3 kilometers. Temperature, see it is more cooler, 27 degree, but humidity is 42. Whereas here humidity was 30%. Okay. Here humidity is 42%. And then you can see the forecast. What could be the weather in next couple of hours, 2 hours, 4 hours, kind of thing. So this is how you should interpret and try to see as much as like you want to see. Let's say let me get Srinagar, Srinagar Airport. Okay. METAR missing. Yeah, as of now they have not put. Okay, so there is no METAR over here. But there is a forecast been made. The current METAR is not available, but there is forecast been put up over here. But this is again 7 hours back. Okay, so there will be the last 7 hours. The visibility was good. Wind was just normally flowing 5 knots. With light rain or mist. Okay, so when you write no significance, na? Okay, like see here haze. So haze. Okay, depending like that. Okay, or you can write smoke, smoky little bit or kind of thing. So these are the information which will help pilot to decide what kind of weather he can encounter. See few clouds at height of 8,000 feet, scattered clouds at height of 15,000 feet, broken clouds at height of 8,000 feet. So depending upon different heights, they have, let's say again they have given scattered clouds, broken clouds, all that information. So that's why if you see when you are flying a commercial aeroplane or civil aeroplane, weather is very important. As of now, drone will not have much worry part uh, as we are not flying the drones in a very high altitude or kind of far off locations kind of thing. Okay, you are limiting yourself with geofencing range within your visual line of sight and altitude of 400 feet only. Okay, so mostly at your location when you're flying the drone, there are not from a cloudy perspective or the weather perspective. Definitely visibility will play much bigger role. and the most important is the wind speed and the wind direction. Okay, and that also the type of drones you are flying. Only then only. But you should always have a habit. How is the weather in flying conditions? Okay, so international standard atmosphere. This we have seen during the Q&A subject also. Uh, The International Standard Atmosphere is the static atmosphere model of how the pressure, temperature, density, and viscosity of the Earth's atmosphere change over a wide range of altitude and elevations. Okay, it has been established to provide a common reference for a temperature and pressure, and consists of tables of values at various altitudes, plus some formulas by which those values were derived. So there is a table, table which defines a location to location. Okay, it depends upon latitude to latitude, because again your atmosphere will change with respect to the altitude or elevation, and again with the geographical location. So whatever um, pressure, temperature, density, and viscosity of you see of the earth, let's say whatever you have in Mumbai, not necessarily whatever you have in Mumbai, the same you will encounter in Karachi, Pakistan, or same thing you will encounter in Dubai, or maybe not encounter same in Paris, or same you may not be encountered in London. So again, every geographical location, these four parameters will be different. So based on the location, geographical location, these parameters will change. And based on the historical data, they have some standard tables created, okay, which could be available for a pilot to refer, so that they knows at that particular altitude for this particular location, I will more or less will have encountered this pressure, this temperature, or this density, or this viscosity of the parameters over there. Okay, it could be pressure, temperature, density, or viscosity. Okay. So, International Standard Atmosphere, the ICAO published their standard atmospheric ISA as MSL temperature, that is mean sea level temperature at mean sea level temperature would be 15 degrees Celsius. So, they have standardized certain values, okay, but it would be plus minus, not necessary, but this is at a very standard level. Okay. At mean sea level, my temperature would be minus 15 degree. At mean sea level, my pressure would be 1013.25 hectopascal. Whereas mean sea level, the density would be 1225 grams per cubic meter. Whereas the lapse rate, okay, the temperature difference, what we call, will be 1.98 degree per thousand feet up to 11 kilometers. That means in troposphere, as I am climbing, let's say from zero at mean sea level, my temperature would be 15 degree. So as I climb thousand feet, what would be my temperature? So practically we will use lapse rate as 2 degree. Okay, so this is rounding off we are done. 1.98 is actually 2 degree per thousand feet. So as I climb thousand feet up from the sea level, my temperature will drop. So my temperature from 15 degree it will become 13 degree. As I climb further up, let's say another 1,000 feet, my temperature would be 11 degree. So that's how my temperature difference would start as I climb up in the troposphere, and at certain rate it will go into the minus. That's why the range of a troposphere is given from from the sea level 15 degree to minus 56 degrees. Are we clear on the lapse rate, or do you have any questions over here?
No, sir.
Right.
No.
So important part is remember the lapse rate.
Lapse, right?
As you climb the area, your temperature difference will reduce. So if it is 15 degree, you as you climb up in the sky, let's say from Mumbai you go to Lonavala. So Lonavala, let's say it is 1,000 feet. I'm just giving an approximate. Okay, let's say Lonavala is 1,000 feet. So definitely when you go to Lonavala, you feel cooler, right?
Yes.
Yeah.
You're above the sea level. Sea level is like as Mumbai airport is what 8 meters. So sea level will be zero. So from 0 to 1,000 meter difference, definitely your 15 degree will reduce to 13 degree or 12 degree kind of thing. So you will feel cooler at Lonavala, or you go to Mahabaleshwar, okay, which could be 1,500. in height. So probably there you will might get 11 degree temperature over there. Okay, that's how you calculate the difference in the temperature. So because temperature again, if there is a low temperature, your density will low. Higher the temperature, I mean the cooler the temperature, your density will be high. Okay, again as density is high, pressure would be also there. So see all these parameters plays, and they have each other dependency on it. Okay. So types of pressure. Now we have seen the difference in the temperature. Now we'll see with respect to the pressure. In the aviation community, yesterday we have seen this term. The term QNE, QNH, and QFE are used to describe the standard pressure, local altimeter, and the field elevation respectively. Now QFE is field elevation. We said field elevation means height. When we are talking about field, we are talking about the height. QFE is the altimeter pressure setting at the takeoff location where indicates the height. So what would be the height when the drone is on the ground?
0.
Zero. So your altimeter is showing 0 degree.
Zero.
Okay. So as you take off and you climb, let's say you climb 8 meters. So what will the altimeter will show?
8 meters.
8 meter only.
Right? So whereas QNH is nothing but nautical height, QNH is the altimeter pressure taken at the takeoff location reduced to mean sea level under the ISA condition, which is indicates altitude. Okay, so it will show you the altitude from the mean sea level part. Whereas QNE is the altimeter pressure setting at a standard atmospheric level. Okay, that is 1013.2 hectopascal, which indicates the flight level. Okay, so from a drone perspective, for us, most important is the QFE, the field elevation or height at which the drone is flying. So remember, whenever somebody asks at what height you are, either it is told in a meter, depending on whatever you are seeing on your RC controller. You should tell, okay, it is whether it is at 8 meters or 10 meters or 12 meters. You know, when you are actually, you will see this when you are doing it on a simulator environment also. When you are flying a simulator drone, you will see because you will be always flying. You will understand the more height you fly the drone, when you are in up in the air, it is good, but when it is going away from you, you will feel that your drone is coming down. Okay, so it will give you a illusion that you're as you're doing a pitch forward, your drone is actually trying to descend down, but it is not actually descending. It is at the you have to see the height at that point in time, what is showing on your screen. If you see that height is not changing, your drone is at the same height, irrespective of whether where it is on the with respect to the ground. Okay, so you need to maintain that height as you are flying the drone. Like you fly normally 8 meters or 10 meters up in the air. So a lot of people see that as they do the pitch forward, they assume that drone is going down. So they will, naturally they will trend to give the throttle to the drone. Okay, so this is the same diagram what we seen yesterday. So QFE is the height with respect to the ground or the aerodrome. The difference between the aerodrome and the sea level is the elevation of that particular location. So the QNH, what we calculate, is the from the mean sea level plus QFE. Okay, that is called altitude of that flight. Whereas the flight level, what we talk is the QNE, which is measured with respect to the standard air pressure, is 10013.2 hectopascal. So this some points you need to remember, okay, when we are actually talking respect to our flight levels or where we are actually flying our aircraft or where we are flying the drone. So when we are flying a drone, most important is the height or QFE, what we need to communicate with our fellow co-pilot, or if even the instructor is asking, or anybody who is there, or even your documenting at what flight, what height you are actually going. Like for example, in agriculture spraying, depending upon the type of crop, you will decide at what QFE level you will be flying your drone. For example, you are spraying in a rice field. Okay, rice field don't grow very high up. Okay, so in that you might tend to keep your drone somewhere around 5 meters, 6 meters, or max 8 meters in height. Okay, whereas in sugarcane grows almost like 8 to 10 feet in a height. So there you will normally fly your drone somewhere around 10 to 12 meters height. So depends upon again where and for what reason you are flying. Based on that, you define the height of your drone operation. Okay, that same thing. So noise. Now, okay, so we have seen the temperature, we have seen the pressure. Now let's see the wind. Okay, how wind affects on the drone. So to measure the wind speed, we have a device called anemometer. The device that is used to find the digital anemometer is there. It is the analog as well as digital. So you will see it will have a fan in the analog. So as the wind flows, it will start rotating. So the measure the rotation of this wing and convert your inputs into digital output. While digital anemometer, the pocket size and complexity.
Anemometer.
So digital handheld anemometer are available in market, which a drone pilot must always carry with them to cross-check wind speed at the time of operation. So whenever we are flying a drone, we'll normally check the anemometer, the speed of what at the wind is flowing. The wind speed should not be more than the permitted limit by the manufacturer at the time of the drone operation. So for my drones, we do not have much of the issue on the wind speed because they are permissible up to 12 to 15 knots of the wind speed. Okay? So in case you do not have anemometer available with you, you will always find on the airport or on the aerodrome or wherever you are doing a fly location a device called windsock. Okay? So you will always have something like this, okay? Windsock flying at the area. So even at our flying base, we have a windsock. Whenever we do flying, we always first make sure that we fit the windsock, so we know what is the wind speed. So in a normal scenario, when there is no wind flowing, your windsock will be always hanging down. Okay? It will be vertically down. But as the wind is flowing, if there are five segments or five sections on this, like if you see this one, two, three, four, and five. So depending on the speed of the windsock will fly, okay, or windsock will blow. So as the wind is entering the windsock, if the first section is horizontal, that time we say it is 3 knots of wind blowing. If first two sections are there, it will be multiple of three, so 6 knots. Then three sections, 9 knots. Four sections, 12 knots. And all five sections, it will be 15 knots. So beyond this, the wind is very high or very high speed. We can feel the wind. Okay, so that will be something around 15, more than 15 knots. If it is more than 15 knots, that means that is not a good wind for actually flying the drones. Okay, so you should avoid as much as possible flying beyond 15 or 18 knots of wind. Okay, are you clear on the windsock? If you see the windsock, you can tell like if this is like this, it is 15 knots. If it is the last part is bended, then you can say it is 12. So you multiply, you see how much vertical parts are there. Like if you see one, then it is 3. If it is 2, 6. If it is 3, 9. If it is 4, 12. If it is all 5, and it is 15 knots of wind flying. Clear?
Yes.
Clear, sir.
So this is a mandatory equipment in our marine industry.
Yeah, yeah, yeah. Everywhere. I mean, you should. I mean, aircraft and wherever you are encountered with the wind, I see. You know what? How much wind is impact, impact, up, performance of air, all that really required for us. See, this is not really accurate, but at least it gives you some estimation. And then you also give you the direction.
So your voice is breaking.
Can you hear me now?
Yeah.
Okay, so what I'm saying is this is not very accurate. Okay, but at least it will give you a rough estimation of the wind. Okay, based on whatever the sections are in a vertical part or in a horizontal part. Okay, so as we see more and more horizontal parts, horizontal sections are being shown, the more higher the wind is blowing over there. Okay. Now let's see what are different types of wind. So a gust is a sudden increase in a wind speed, often with a change in direction. Okay. All of a sudden you will see there will be increase in the wind speed and also change in the direction of the wind, but not lasting. I mean, not lasting or lasting less than 1 minute. I mean, it is within a minute. It is just a temporary. Okay, and it is a local effect. All of a sudden you will see there is a breeze, but it will not last more than a minute. It will be always less than a minute. Okay, and then there is a period, or after that you will see it is a calm period. Okay, lull is a period without waves or wind. It will be like a silence. All of a sudden everything will become silent after the gust. Okay, so gust will last for less than a minute, and then all of a sudden everything will become silent. A lull period, what we call. So that's the definition of the gust and the lull. Okay, the gust is a sudden increase in a wind speed, often with change in direction. Okay, all of a sudden you will see that change in the direction, lasting less than 1 minute, and it is a local effect. Not necessary as you are outside your office, all of a sudden you will feel the gust. But not necessary a person standing at let's say Airoli station, he may also feel the same. So it is a local effect. At that point, at that location, you will feel this change all of a sudden, a wind flowing. Okay, so this is basically because of the all of a sudden the temperature as well as the pressure differences and all that things creates a sudden gust in the environment or in the atmosphere for that particular location only. Okay, so lull is the period without waves. So after gust, you'll always see a lull. Okay, it will be a silent period with no waves or no wind kind of thing. Okay. Whereas squall is the sudden increase in a wind speed. So here also it is a sudden increase in wind speed. Both location you see sudden increase in a wind speed, often with change in direction. Here also change of direction is, but lasting 1 minute or more. Okay, so this is longer and cover a wide area. So this you will not encounter in a small space or small location. This will always you see in a bigger, like हम लोग cricket खेलने जाते हैं, बड़ा ground है, okay, or a big area is there. Like suppose I go to Mahabaleshwar, Panchgani, where tabletop land है, big area, big wide area, plain area is there. There you will always see the skull, okay, which will be more than a minute and can cover a wide area. A skull is really important to be predicted. Carelessness on the part of the skull can result in crash of the drone and hence the loss. So if you see, you can see this type of wind coming also because it will encounter, it will be more than a minute. It will be with lot of dusty particles and all the things you can see. So a lot of time you can see actually this skull. The gust you cannot see, you can only feel. All of a sudden एकदम सा मस्त breeze आ जाता है तो बोलते हैं ना आज कितना अच्छा मस्त ठंडी हवा आ रही है or how it is a good kind of you feel good when because it lasts less than a minute and it just give a good feeling. Okay, but whereas in a squall it will be a very high speed wind, okay, change in direction and covering large area. So we'll try to avoid this kind of things. Okay, this could impact our drone operation. Okay, we are talking from a drone operation perspective. So if you see such thing happening, it will take some time to reach also. You can see it from the far also. So that point in time, you should immediately take a decision to land your drone safely. Okay? So if you do not do that, probably if the swell is very high or more, probably your drone can go haywire and it could cause crash. Okay. Okay. Gale. Now gale and hurricanes. You see, gale exists when the wind speed exists at 33 knots. So where if you see squall and the gust, they may be more than 15, 20 knots. Okay, but not certainly not at 33 knots. 33 knots is gale exists when the wind speed exists. Sorry, exists exceeds 33 knots. If it is flowing, the wind is flowing above 33 knots, then it is called gale. If the wind is flowing at 60, more than 63 knots or exceeds 63 knots, then we call it as hurricane. Okay, so these are very difficult situations. Even in these scenarios, people try to avoid flying the aircraft. So forget about the drone, but even people don't fly aircraft in this kind of scenarios. Okay?
Yes.
They will try to avoid the path of this gale or the hurricane locations. So relation between the speed units in aviation, generally speed should be measured in knots, but as per ICAO standard, unit for speed is kilometers per hour. So you should know how to convert from a knot to kilometers per hour. So one knot is equivalent to 1.852 kilometers. So when we talk about three knots, so three knots into 1.852, so roughly it will be six less than six 5.5 5.5 kilometers per hour kind of speed you will. Okay, if you want to convert into miles per hour, okay, because miles per hour is used obviously in British standards or UK standards. So they will ask you the wind speed when you are flying aircraft. Their ATC will always talk in miles per hour. Okay. So they will follow their units. Whereas this is international or American standards, the kilometers per hour. Okay. So depending upon which geographical location, which area you are flying, and based on what ATC you are communicating, accordingly you need to communicate the unit. Okay, but standard unit as per the ICAO is kilometer per hour when we talk about the speeds. Okay, so every time you have like 15 knots, so 15 into 1.8, you should know and calculate and due to them in that kilometers per hour the speed unit. Okay, so now we have seen the temperature, we have seen the pressure, we have seen the wind speed. Now let's see from the density or viscosity based on the cloud, because the more cloud you will have a denser environment and all that. Okay. So cloud is nothing a mass of minute water droplets or a tiny crystals of ice formed by the condensation of the water vapor in free air at the considerable elevation. As the clouds are formed at some height over the surface of the earth, they can take various shapes. So, as we see, the cloud are formed because of the mass of the minute water droplets or tiny crystal ice formed due to the condensation of the water vapor in the free air. Okay, so they take various shapes. So, according to their height, expanse, density, and the transparency, clouds are grouped in four types. So, what are these four types? It could be cirrus cloud, it could be cumulus cloud, it could be stratus clouds, or it could be nimbus clouds. So, depending upon how the cloud is there, based on at what height, what expanse, means how big it is, how denser it is, and the transparency of the cloud. Okay, we have seen a lot of time through the clouds also we can see the sky. They are very transparent kind of thing. Sometimes the clouds are very denser. Okay, we can't see. Sometimes the cloud is darker. You can't see anything in the sky. You suddenly you lose the visibility and all. Okay, so depending upon again the height, how high the clouds are there. So depending upon all these parameters, your type of clouds are defined. So what is cirrus cloud? Cirrus clouds are formed at a height of altitude of 8,000 to 12,000 meters. They are thin and having feathery appearance. Okay, this is very important. Feathery in appearance. They are always white in color. You can see they are very thin, okay, and feathery kind of thing. So looking at that this type of clouds, you can know this is cirrus clouds. But if you see cumulus clouds, they are also formed at around 4,000 to 7,000 meters, but they exist in patches. Okay, you can see they are more like a patch and denser. Okay, but they are scattered. Can be scattered here and there. So they are scattered kind of thing. Okay, cumulus are like looks like a cotton wool. Here we talked about feathery appearance. Okay, whereas here they looks like a cotton wool. So when we look at the different type of clouds, seeing their appearance, we can know what type of clouds are there. This is cirrus cloud like a feathery appearance, whereas this is like a cotton wool. We call them as a cumulus clouds. Okay. Now the third, fourth, stratus cloud. They are the layers covering the large portion. See here, they are in a small patches. Okay? This is in a patches. These are also in small area, certain part of the sky you will see. But if you see stratus clouds, they are layered clouds covering large portion of the sky. These clouds are generally formed either due to loss of heat or mixing of air with different temperatures. This you will see during mostly like if you wake up early morning, somewhere around 5 o'clock, 6 o'clock, before the sunrise, you will see this type of clouds form because there is a temperature difference at that particular level. But all of a sudden, sun rises and 7 or 8 o'clock, you will see these clouds get disappear because temperature will become normalized. In the morning or the evening, you will see this type of stratus cloud forming or in the sky at that particular location. Whereas nimbus clouds are the black and gray. They form at the middle level or very near to the surface of the earth. They are extremely dense and thick, so they don't have any shape. You will see complete cloud cover. Okay, especially during rainy season, you would see this type of clouds. Right? You would have seen this type of clouds. So you will see very low visibility, completely dark, black kind of clouds, and they are covered everywhere of the sky, and they are very low to the earth. That is the time when you will see rain happening and all that. So nimbus clouds are basically responsible for black gray clouds, and they will be closer to the earth, and they will be extremely dense and thick, and they will be covering a lot of water molecules or water vapors in it. Actually, they appear on the land with the difference in the temperature. They will start raining as you see the humidity increases. It starts raining through this cloud. Okay, so weather impacts on US operation. Like for example, weather has a cloud base less than 900 feet or distance of cloud to 8,000 feet. So it will basically impact your visual line of sight. Visibility less than 3 miles, it will also impact your visual line of sight. Fog, fog and airplane noise, short circuiting electronic, water molecules getting inside your motor or even your body or the train. It will not only the flying condition will have a VLOS impact, but even it will impact the electronics or avionics of your. A lot of time we have seen icing happening when you are flying a drone in like Kashmir area, Ladakh area, or in European countries, or even in America, Canada location. A lot of time we will see that there is icing happening on the drones. So this will impact your performance, the physical performance of the people. Sometimes even you will lose the aircraft because it will not be stable. Okay. Then lightning. Lightning effect is not much on the drone because unless you are flying an aeroplane kind of drone, so you will see a drop communication due to radio frequency. A lot of times, lot of communication due to lightning. Okay, wind or wind shear, huge wind blowing. So it will be loss of control, inability to return to the home or mission. A lot of times we have seen people using the drone in wind or wind shear kind of environment. Okay, and then moderate or great turbulence, reduce mission duration. So a lot of time you have to abort your mission or you have to land your drone wherever it is in the air, okay, or maybe you have to call it back, return to home or return to land, kind of thing. Okay. So if you see, with respect to the cloud distance and visibility, see, here I am actually on the ground. I am trying to control my drone. So from me, don't consider the miles as of now. Just think from a perspective of kilometers. So it will be easier for us. Say this is zero point 0.5 miles. So from your location till for zero point 0.5 kilometers, okay, you can see your drone very clearly. But it is as it is moving away. You see, 1 kilometer it will be less visible. As it moves further away, 1.5 kilometers, it will be much less visible. So at 2 kilometers, it is more or less invisible kind of thing. And beyond that, it will is not available only. So it becomes very. So in a dense fog situation, you need to see how much visibility you can see. So ideally, in a normal scenario, it is said that VLOS condition depending upon size of the drone again. Okay? Again, depending on the size of the drone. Just give me 2 minutes. I have an important point.
Yes.
Okay, sir.
कहाँ से बात कर रहे हैं? Okay, and which location Mumbai you're talking? Okay, and how many people would be traveling? Two plus one. Okay, okay. So, and how you will be traveling? Okay, so we have event on 22nd of March, where the event will start at 5:30, and it will start as you reach the site. You will be having a registration, and your tent will be assigned to you, and then we'll have snacks served to you. And as the evening progress, we'll see some objects in the evening first, satellites and all the objects what are there in the evening sky. We'll see, and as the dark starts or the night starts, we'll start with the AV session. We'll talk about the astronomy and all the things, and then we'll progress with the another observation session, and then we'll proceed for the dinner. Okay, it will be a pure veg dinner, and then after the dinner again we'll have a small observation session. Whatever the objects has appeared after the dinner or during the dinner time, we will see that, and after that observation session, we will proceed for a small entertainment program also, where we'll be having a guitarist playing a live music and the songs for 1 hour until. So by 12:30, 1 o'clock, we'll end our session over there. People will be, allowed to go for some power nap or rest, because you will be more or less standing, walking here or there, and all that thing. So almost 6 hours would pass out. So you need little bit rest. So you will be resting in your tent from 1 o'clock to 4:30. Again, we'll wake up at 4:30, and then we'll try to see the morning sky. So morning we'll have moon and other constellations and objects in the sky. So we'll be observing. Again, morning we'll see the satellites and all the things. And then by 6:37 we'll have the sunrise. Okay, so post sunrise we'll be having a session of rocket launch, and after the rocket launch we'll have the breakfast, and then after that we'll have a group photo, and then we'll close down our session. So by 8:30 we'll have closer of our session. Yeah, so there is Mars and Jupiter is.
No issues. No, no problem, sir.
Okay. So we were talking with respect to the cloud, the distance and the visibility. So as you move away from your location, more and more you are further away, the visibility of the drone is very less. So in a normal conditions, it is said that under VLOS situation, you can see up to 2 miles to 3 miles. Okay, but beyond that, your visibility is zero. Okay, you can't see. So you always have to fly drone within your visibility diameter. So even if it is seeing 2 miles or 3 miles, you should always take 50% of it. So you should roughly fly your drone somewhere between 1 or 1.5 miles of range. Or in a normal kilometer side, I would say you should not fly your drone more than 1 kilometer or 1.5 kilometers away from you. And you should be judgmental. Again, these values are not very standard values. This is again depending upon the factors like what kind of visibility, where and when we are flying, and again person to person. Okay, because every person's visibility or the eyesight is different. Okay, so what you see, I am not necessarily I will see the same thing with my eyes. Okay. So cloud and fog forms both form when the water vapor condenses or freezes to form a tiny droplets or crystals in the air. Clouds can form at many different altitudes, whereas fog only forms near the ground. So you in the winter you must have seen the fog, right? A lot of time you see the fog. The fog is always near to the ground or near to the watery bodies. Okay, wherever there is a river or especially in a valley, which is very cold and all those location, you will see fog getting formed over there. Okay, whereas cloud will be always at a height or at altitude. So fog is defined as a cloud with its base at or a very near the ground. So fog is also type of a cloud only, but it is more closer to the ground. Fog caused by the cooling. As the air cools, it becomes denser and drains into the lower areas such as river valleys where the thick fog accumulation may occur. So that time you see here in the picture on the right side, you could not see at least 50 meters from the location. The person who is taking the photograph, he can see that within 50 meters also he is not able to see the road properly further. Okay, so that's the very difficult. So in this scenario, we don't drive. Forget about the drone flying. We do not drive also in this kind of foggy scenarios. Okay? So fog is caused by evaporation when cool air moves over the warm water. Enough moisture may evaporate from the water surface to produce saturation. So depending upon different scenarios, okay, fog can be caused by cooling as well as caused by evaporation also. So different types of fogging is happening at a different place. Icing. Now, when we have a icing condition, okay, this is more dangerous and lot of aircraft accidents has happened uh, during the flights, and because of the icing not done, okay, de-icing, what is we call as a de-icing activity. We have seen lot of air crashes happening because lot of icing was formed, and the sensors what are there on the wings, they are blocked because of the icing, and often they are giving wrong inputs to the system, and which has caused the malfunctioning of the airplane when they are airborne. Okay, so freezing rain is a common ahead of the warm fronts in the winter. The serious icing occurs when the aircraft is flying near the top of a cold air mass beneath of a deep air of a warm air. Okay? The raindrops are much larger than the cloud droplets and therefore give a very high rate of catch. That means what? You know, when this freezing in the icing happens on the wings, the structure of the wing changes. It will impact the airflow on the wing. It will degrade the performance of the aircraft. In the freezing temperature, normally this raindrop will make ice on the wings. Okay, so lot of time the pilot before flying, he will always inspect the wings. Okay, if there is icing on the wings or not. If there is icing, the bigger aircrafts like Boeing or Airbus, you know, they have a feature called de-icing feature. So they will activate the de-icing effect things on those wings, which will actually evaporate the complete ice formation on the wings, and then only they will fly the aircraft. Okay, but the smaller aircraft like Cessna or small charter planes, they do not have this kind of feature. So sometimes the service guy, you know, he will manually try to remove this ice because this is just little ice. You know, as you clean it with the blade or something, you know, a structure, you can remove this ice, or you can put a hot water on the wings. Okay, like a lot of time, lot of airports also do these things. They spray a hot water on the wings, so that will evaporate your the icing effect on the wings. Okay, so how structural icing affects the flight? So as we see, effect of icing are cumulative. So what will happen, as we said, if there is more icing on the wings, it will impact the air pressure. Okay, it will create what lift will decrease. I mean, it will decrease the lift. The weight will increase because weight has increased because the ice is formed on the wing, so weight will increase. That means what? It will go down. Thrust will also decrease because the performance is not. It is not able to generate enough lift. If there are icing built up on the horizontal and vertical stabilizers, this will also impact your pitch moment, okay, or your even yaw moment because rudder will not be functioning properly. So to avoid all this, and then stalling, okay, the stall could impact because you are not able to get enough push pitch. So what we will try to do, if you're as you're flying, and you know, this is what actually affects the air performance. So as you're trying to give the pitch, you will see that your airplane is not climbing. So what you will think, that I may have to give more this thing angle to the elevators. Okay, so you as you give more angle to the elevators, if it is go beyond the acceptable angle of attack, will stall. Okay, so that is where the stall happens. So you have seen, if you go and search on YouTube, whatever the air crash has happened due to icing, they are because of this stalling effect. Okay, the pilot would have given more angle of attack to get the height of the aircraft, and when it is beyond the acceptable angle of attack, the aeroplane will stall. And if it is gone beyond the control of the air pilot, the stall will mean the crash. I mean, the aeroplane will fall dead rock on the ground. Okay? It will not get time, whatever the height it is. Like it will happen in a moment, like the before he could do anything. And so it is always avoidable, even whenever they are doing pitching of the aeroplane to climb. They will not climb at a very steep angle. Okay, they will gradually climb, because if you try to give more pitch angle, uh, where the possibility of your aeroplane getting stalled is high. So pilot will avoid that tricky angle climb. Okay? That's why when they are climbing, you must have seen a lot of time they don't serve drink or the food, that point. So once it is at a very stable flight, they know now next 1 hour we will be flying at this, or we'll be cruising at that particular altitude. Then only they will start serving you drinks and water and taking that. And as they approach the descent, then they will stop all their activities, and then they will announce that we are going to. So you will not feel the climb and the descent, because they are doing it very gradually. They are not doing it very steep. Similarly, during the icing also, if you try to give more pitch, it can affect the air performance of the craft, and stalling can happen as the speed increases. Okay. So apart from icing, lightning is also one of the factor could affect. Basically, these affects uh, your communication channels. Lightning causes the thunder sound from the shock wave, which develops as a gas in the vicinity of the discharge, experience a sudden increase in pressure. All of a sudden, you will feel the pressure on the aeroplane. So most of the time, aeroplanes or the aircraft pilots will try to avoid, when they see lightning happening in front of them, in particular cloud and all this. So either they will climb and go above that cloud, or they will try to go on the sideways of the cloud. So as much as they will try to avoid this type of situation. So lightning occurs commonly during thunderstorms, I mean during winter, rainy seasons, as well as other types of energetic weather systems. But volcanic lightning can also occur during volcanic events, like you are flying over the Indonesia and all this, there where you have volcanoes and all that thing. That the air is very hot, sulfuric air kind of thing there. So you will see a lot of volcanic lightning happening at those locations. People will avoid flying in those locations. There was the one very famous, not air crash didn't happen, because pilot was able to land the aeroplane very safely. There was an aircraft going from UK to Sydney, I think. Okay? It was a Boeing aeroplane. I think. So as they were flying and they were near Indonesia, the volcanic was happening, and it's a huge aeroplane with four engines. Okay? The pilot was seeing this volcanic lightning, or there was a lot of issues on the visibility part also, and he was seeing a lot of lightning happening. His windshields were also not proper or not visible for him properly, and a lot of ash was getting stuck on the windshield and all. And all of a sudden, his engines also started. I mean, not started. It started stopping. They were actually going down. He lost all the four engines. In that scenario, it was a scenario where the possibility of survival was almost zero. Okay, almost zero. And so the pilot makes the announcement of like Mayday, Mayday, near fall kind of very chaotic. But pilot keep on flying. So now he's flying the aeroplane without engines. Okay? So there is no power to the engine. So without engine, he's gliding the aeroplane, and he lands on a nearby airport without an engine. So there is one book also. One of the passengers from that aircraft, a lady passenger from Australia, has written a book on this entire incident, flying without engines or something like that. Name of the book. It's a very famous book, and it encounters tells about the complete journey from UK to London and how the aircraft was able to land safely by the pilot and all. You can search this on the YouTube video. Aircraft. Very interesting. I mean, 55 minute video is there about this entire incident. It will give an idea how some pilots are extraordinary. How they actually the pilots are being trained or tested only in such kind of situation. Rest of the situations are very normal. You are doing all day to day routine work, flying, all and rest of the things are taken care by the autopilot. And all. But still, the job of a pilot is a very stressful job. So many lives, the aircraft, everything is in your hand. That pressure is there in your mind.
Yes, sir.
So wind shear, sometimes referred to as a wind gradient, is a difference in the wind speed or a direction over a relative short distance in the atmosphere. Atmospheric wind shear is a normal described as either vertical or horizontal wind shear. So normally you will see wind either flowing from horizontal directions or sometimes even vertical. So a lot of time you will see it affecting the things going in the air. So all of a sudden things will fly in the air, or it will come down, or there will be a lateral movement across the horizontal. Okay, so vertical wind shear is the change in the wind speed or a direction with change in altitude, whereas the horizontal wind shear is the change in the wind speed with the change in the lateral position from a given altitude. So at particular location, if there is a horizontal wind shear, it will see the change in a lateral position, whereas in a vertical wind shear, we'll see change in the altitude. So let's see how it sees in a pictorial format. So if you see vertical wind shear, you can see it is changing its altitude over here. Okay, from below, the wind will go upward direction. Okay. Whereas in horizontal wind shear, you will see it is a lateral movement on the ground. Okay. It is not change in the altitude, but it's a lateral movement of the wind. Okay. Drastic change in wind speed or direction over relative short distance in the atmosphere. Okay, so that's how you have. So both type of wind shears are not good for flying the drones. So if you encounter you see there is a vertical wind shear is happening and it could be impacting your drone performance, you should always try to bring your drone down. Okay. Either but when you have a horizontal wind shear, you will see that there is a lateral movement between the drones. Or if there is a vertical wind shear, you will see all of a sudden your drone is moving up high in the sky. Okay, even though you are not giving throttle. So that time you should try to see how you can stabilize. Okay, your drone will also try to stabilize on its own because it is getting inputs from GPS, it will getting inputs from the IMU and all that thing. So it will try to do it, but sometimes the wind shear is so high, it will not the drone will not able to withstand that push of the wind. So either it is vertical or horizontal. You try to see if you are it is within your control. You try to control it, okay, and bring it to the normal condition. If you are not able to do it, you may initiate an RTL straight away. So automatic let the drone compute on its own and come down. So rather you trying to do it manually and all that. So in that scenario, it is always advisable to trigger a RTL or RTH on the drone. Okay, so turbulence is a sudden violent shift in airflow, causes wind, storm, jet streams, objects near the plane, particularly the mountain range. So, lot of time, that's what I'm saying. You will see this turbulence when you are flying in the sea regions also, like wherever you like, especially if you are flying from let's say Mumbai to Chennai, and you are going across, you are crossing to Tirupati mountains or those mountains, the very hilly, and in that location also you will see the slow and fast wind blowing. Okay? So there is a change in this wind speeds, and also this causes a lot of turbulence in the air. Okay? Or even as I said, near the where there will be difference in the temperature causes the hot air and the cold air motions, and have a turbulence there also. Okay. So turbulence, normally pilot will always try to either, if they're encountering the turbulence, they will either climb down or they will climb up. So they will take the permission from the ATC, what is that they need to do. ATC would tell that okay, you climb down from 20 to 10,000 feet, or maybe from 20,000 you can ask you to climb up to 25,000 feet from that turbulent area on your flight path. So they will normally tell you the vertical movements up and down. Okay, they will not give you gradually left, right, or lateral movements until unless they are required, because lateral movement means you have to do banking of your aeroplane. So up and down is very simple and easy movement, because you are just changing the pitch of your plane. So either you climb, or you just by losing the altitude you can come down. So that's a very simple operations you can perform. But if you have to do a lateral movement, you have to change with the ailerons. Okay, so you have to bank, or you have to do the turn using the radar. So this is putting a lot of pressure during a very critical time. So it is always avoid having too much change on the surface structure of the aeroplane also. So you will always try to climb or descend in this scenario. So similarly for the drone also, if you are not able to bring your drone to the return to launch or anything, there is option to land. So you can trigger that land position also. So wherever the drone is flying at that location, it will try to land safely on the ground. Okay, so light turbulence momentarily causes slight changes in altitude or attitude, or a slight bumpiness. Occupant of the airplane may feel a little strain against their seats. Moderate turbulence is similar to the light turbulence, but somewhere more intense. However, no loss of control on the airplane. And during normally this light or moderate turbulence, you will not have any loss of communication or control on the airplane. But as the intensity is severe, okay, now you see in a light, moderate, or severe conditions, how the difference is there. In a light turbulence, you might rise or drop by 1 meter. Okay, whereas in moderate, you might rise and drop between 3 to 6 meters. But in a severe turbulent conditions, you will encounter 30 meters difference in your up and down. So that is the time when you will try to have a lot of bumpiness when you are flying. So depending upon type of turbulence, pilot would be making announcement. We are encountering a moderate type of turbulence or light type turbulence, or if there is a severe. Okay, so that is point in time when they will ask you, to return to your seats. No washrooms, no drinks, no food will be served, and you are requested to be seated with the seat belts on and all that. That's right. So when you have a severe turbulence, you should always avoid movements in the aircraft also. You must have seen this kind of announcement, right?
Yes.
Okay, so with
Yes, sir.
that, we complete our weather and meteorology. So, any questions you have on weather and meteorology?
No, sir.
Right? You are clear with this. So,
Yes.
let's take a break, and then we'll come back by 11:20,
Okay.
Yes, sir, sure.
when we'll start with the drone equipment and maintenance topic.
Okay, sir.
Okay, sir. Okay.